Hello, this is Mr. Huber. In this lesson, we're going to learn about solving polynomial equations using their factored forms. Okay, let's talk about something called the zero product property. It's going to be essential to how we can solve with factored forms. The zero product property says that if we have a product of two numbers and it's zero, one of the numbers is zero. So for instance, if x times y equals zero, then either x or y, or both of them, have to be equal to zero. That's the only way we're going to multiply and get zero, is if a factor is zero. So we can use that to solve equations when we have them in factored form. For instance, if we have x minus 6 as a factor, x plus 2 as another factor, right? These are multiplying each other together. This is one factor, this is another factor. Two binomials equal 0. That means one of them is equal to 0. One of the factors, x minus 6 or x plus 2, have to be equal to 0 in order for the equation to come out to 0 when I multiply them. So I can use that by taking each factor, x minus 6, set it equal to 0 as its own equation, x plus 2, set it equal to 0 as its own equation. Then I add 6 to both sides, and I'll get x equals 6. Subtract 2 on both sides, I get x equals negative 2. So my two solutions would be 6 and negative 2. These are the solutions. They're also called the roots or the zeros. So roots or zeros is another term for that. So solutions, those are the numbers that if I plug them back into the equation, they would make this equal to 0. For instance, if I plug 6 in here, 6 minus 6 is 0 times, it doesn't matter. This is an 8, but it really could be anything, because if this factor is 0, then when I multiply, I know I'm going to get 0, a zero product property. So take each factor, set it equal to 0, and solve. Let's see what that looks like in a couple of examples here. In this first example, x minus 5 and x minus 1 are my two factors, so I'm going to set them each equal to 0. X minus 5 equals 0, x minus 1 equals 0, and I'm going to solve each of those by adding 5 in this first case, and I get x equals 5. Add 1 in this case, and I get x equals 1. So my solutions would be 1 and 5. You could write that as 5 comma 1, 1 comma 5. X is equal to both those, not parentheses. We're not putting parentheses around it. This is not an ordered pair. Okay, it's not an x comma y. It's two solutions of the same variable. 5 and 1 are both solutions to that equation. Now let's look at our next example. We can take each of these factors and set them equal to 0. So we're going to have 3x plus 7 equals 0. 2x minus 10 equals 0. So it's not like you just look at it like the last one, oh, negative 1, oh, that's great. I had x minus 1, that means 1 was my solution. Oh, plus 7, so that means minus 7. No, because we're going to have a 3 that we have to divide by as well. So when I subtract 7 on both sides, just set these equations up. These should be equations that you can solve without much difficulty. Add and subtract on both sides, then divide. X equals negative 7 over 3. Next example, I'm going to add 10 to both sides, right? Then I'm going to have 2x equals 10, divide by 2 on both sides, and get x equals 5. So negative 7 over 3 and 5 are my two solutions for equation number 2. You have the factors equal to 0. That means we set each factor equal to 0 as their own separate equation, solve for the variable, and we'll get the solutions that if I plug them back in would make that original equation true. When we're factoring, we want to first get the equation set equal to 0, right? We can't say the factors are going to set equal to 5 or 2 or negative 3 or anything else. We have to have the equation set equal to 0 on one side, and we have to have it factored. And sometimes finding a greatest common factor is the first step in factoring the equation. So first let's just look at how to find a GCF from a monomial out of these two binomials. So we've got a binomial here, and we want to find what's the monomial factor that would be the greatest common factor of those two terms. In this case, 12m plus 42n, we have a number that we can factor. We can't factor out an m, we can't factor out an n, because it has to be common to all of the terms we're trying to factor out of. So in this case, we can factor out of the 12 and the 42 a 6. Okay, we can factor a 6 out of both those terms, and we'll have 2m plus 7n. That's an m there. 2m plus 7n. That would be taking out the greatest common factor. In number 4, we can factor out a number and variable. Okay, there's a 6 that's a factor of 6 and 30. We can also factor out a y squared. That's the greatest number of y's we could factor out of any of those terms. And then we would have left over y to the third. Right? When I take y squared out of here, the other factor would be y to the third. Right? If I multiply these together, I get y to the fifth. There's 5 y's here. I'm factoring out 2 of them. There's 3 left over. Here I'm factoring both y squareds out, all right? Both the y's. The whole y squared's coming out. So 6 and negative 5 would be the factors of the coefficient. So this would be the factored form, taking out a greatest common factor of both those terms. Remember, it has to be common to all of the terms, whether it's 2 terms, 3 terms, 4 terms, it has to be common. The greatest common factor has to be common to all of them. And we want to factor out the most, the greatest amount. So now we're going to see what that does for solving equations. Right? We want to get it set equal to 0 and then factor and use the factors to solve it. So the first one, set equal to 0, that's great, in number 5. So our next step then is to find any greatest common factors. So in this case, we can factor out a 2x, and we'll have left over x plus 4 equals 0. So now we want to set all of the factors equal to 0. In this case, we're going to set 2x equal to 0 and x plus 4 equal to 0. We're using the factored form, that zero product property now, to solve. And I'm going to divide both sides by 2, and I'll get x equals 0. I'm going to subtract 4 on both sides, cancel that out. I'm going to get x equals negative 4. So my solutions would be 0 and negative 4. In number 6, it's not set equal to 0. So I need to subtract 15n on both sides here because I need to get equals 0. 6n squared minus 15n equals 0. Now I can use factoring. I can factor out of both those terms an n, and also the 6 and the 15 a 3. So I can factor out a 3n, and I'll have left over 2n minus 5 equals 0. I'm going to set each of those factors equal to 0. So 3n equals 0, n minus 5, 2n, excuse me, minus 5 equals 0. Don't want to forget that 2. Here I'm going to divide by 3 on both sides. I'll get n equals 0. And if I add 5 to both sides, I'll get 2n equals 5. I divide both sides by 2. I'm going to get n equals 5 over 2. I'm going to divide by 2 there. So those are my two solutions for number 6. N equals 0 and n equals 5 over 2. And just like solving any equation, we could plug those back into our original equation. If I put a 0 in here for n and n, 0 squared is 0 times 6 is 0 equals 15 times 0 is 0. I could put 5 over 2 in. I could square 5 over 2 times 6. Then I could do 15 times 5 over 2, and I'll get those come out equal to each other. So you can plug those values back in and make sure they work. Just like any time you solve an equation, they should be what make the original equation a true statement. All right, now looking at number 7, and you should be trying these. In this equation, it's set equal to 0. We need to factor it. There's not a common factor to take out, but we do have one of our special factoring patterns. So I want to recognize that. This is going to be 5y plus 9 and 5y minus 9. It is a difference of squares equals 0. So I can take each of those factors, 5y plus 9 equals 0, 5y minus 9 equals 0, and solve each of those to get my solutions for this equation. So I'm going to subtract 9 on both sides, and then I'm going to divide by 5. 9 over 5, negative 9 over 5. Then I'm going to add 9 to both sides, and the second factor set equal to 0, and I'm going to divide by 5 still, and I'm going to get positive 9 over 5. So I'm going to have 9 over 5 and negative 9 over 5 as my solutions for number 7. All right, and number 8, as you're working on solving this, add a w after the 40. Okay, so we have 12w squared minus 40w equals 0. So when I do this, I'm going to factor out a 4w, and I'm going to have 3w minus 10 equals 0. I can set each of those equal to 0 and then solve. So factor and set each factor equal to 0. So now I'm going to divide by 4 and get w equals 0. And then I'm going to add 10 to both sides, and we get 3w equals 10. I divide by 3 on both sides and get 10 over 3. W equals 10 over 3. Right? So factor, we have different ways we can factor. Greatest common factor is factoring patterns. We're going to see that in this next one as well. And then set each factor equal to 0 to solve. So in number 9, we've got special factoring pattern, but we're going to have to set it equal to 0 first. Don't forget that. We have to subtract 12m on both sides. We're going to have m squared minus 12m plus 36 equals 0. So when I factor this, right, this is a perfect square trinomial. This is going to be m minus 6 times itself. So it means I just set m minus 6 equal to 0. You don't have to write m minus 6 equals 0 a second time. It's just going to give you the same answer both times. I get m equals 6. Okay, because that's m minus 6 times m minus 6. Each factor equal to 0, but if it's the same factor, you don't have to write it out twice equal to 0. So now in number 10, I can add 12x to both sides. Add 12x to both sides, and we get negative 9x squared plus 12x equals 0. Make sure it's equal to 0. Now look for factoring. This is one where I have a greatest common factor. I can factor out a negative 3x. Now if 3x minus 4 equals 0. Factor that negative out, which is nice. I'm going to get negative 3x equals 0. 3x minus 4 equals 0. And I can divide by negative 3 on both sides and get x equals 0. Then I can add 4 to both sides and then divide by 3 and get x equals 4 over 3. So 4 over 3 and 0 would be my solutions for number 10. Again, get the equation set equal to 0, look for ways you can factor, and then take each factor set equal to 0 as their own separate equation to solve and get your solutions for the whole equation. Number 11 here isn't factoring or solving a polynomial, but it is a grammar-related question. Which of these is correct? And sometimes it's like what sounds right, or is it what sounds right is correct? The yolk of the egg are white or is white? Well, actually neither. The yolk of the egg is a yellow or orangish color, not white. Now let's see some application of that zero product property for solving some real-world situations by using factoring of a polynomial. We're going to use this with something called vertical motion. Okay, a projectile is something launched into the air. So you throw a ball in the air, kick a ball in the air, you jump in the air. Okay, something goes in the air and it comes back down by gravity. That's a projectile. A bird, an airplane, those aren't projectiles because they're not going to necessarily just be pulled back into the ground by gravity. They can keep themselves in flight. Okay, so the height of a projectile can be modeled by this equation. H equals negative 16t squared plus vt plus s. We need to make sure we know what those 4 different variables stand for. H, the height. H is the height of the projectile, how high it is above the ground. T is the time the projectile is in the air, and that's measured in seconds. V, the initial velocity. So this V is the initial vertical velocity, vertical up and down. So when you jump in the air, you throw a ball in the air, the initial velocity it has as it takes off into the air. And S is the initial height of the projectile. So the height it starts at. When we're starting on the ground, that height's going to be 0, right? The starting height's 0, S for starting height. So now let's see how we can use that in a situation here. We have a cricket jumping into the air with an initial vertical velocity of 4 feet per second. How long will the cricket be in the air? So how long? We're trying to solve for the t. We have some information here that we can use. We have the initial vertical velocity. We have the height that when it comes back down onto the ground is going to be 0, right? What does that look like? Well, if we have the ground here and we have this cricket jumping and going up, it's starting at a height of 0, so the starting height is 0. We want to know when is it back on the ground. Okay, how long will it be in the air? It's in the air until it gets back to the ground where the height is 0. So h is 0, okay? V is 4, the initial vertical velocity. It gives us this 4 feet per second. And the S is 0. So it's starting at a height of 0 on the ground. We want to find out the time when it will go back to that height of 0. So we can write this equation. We're going to have 0 equals, because our h is 0, we're going to find out when will the height be 0. If we want to find out when will the cricket be 1 foot off the ground, we put a 1 in for the h. Okay, we're going to find out when it's on the ground. Back to the ground is a height of 0 again. Negative 16, that's always there. That's kind of the effect of gravity, pulling something down. Then we have t squared plus 4t plus 0. That initial height of 0, right? We don't even need that there. We have an equation now that we can solve. This is an equation that we can use factoring to solve. Right? We've been factoring things like this. We have a greatest common factor. It's set equal to 0, so now let's look for the greatest common factor. We can take out a negative 4t from each of those terms. And we factor out that negative. Remember, let's kind of change the sign of the other factors that are left over in there. Right? When I factor a negative out of this, when I take out the negative, I need a negative times a negative. My other factor would have to be a negative to get the positive 4t. And now I can set each of these factors equal to 0. Negative 4t equals 0. 4t minus 1 equals 0. And now when I solve each of these, I divide by negative 4 here. I'm going to get t equals 0. Add 1, I get 4t equals 1. And then when I divide by 4, I'm going to get t equals 1/4 of a second. Or 0.25, but you can leave it as a fraction as well. Okay, that's the amount of time the cricket will be in the air. Right? It starts at a height of 0, it goes up in the air, it comes back down, it gets back down to 0 at 1/4 of a second. Right, this right here, t equals 0 solves that equation. That's great. That's when it started, right? The time 0, when it started to jump, that's time 0. It was at a height of 0. It went up in the air, came back down, back at a height of 0 at 1/4 of a second. So we can use that equation, know that negative 16t squared plus vt plus s equals the height. Okay, know what those different parts of the equation stand for, so we can fill in the information we have, solve for some part of that. In this case, we solve for the t, the how long, the time. Right? And we can use factoring, right? That zero product property. We get the equation set equal to 0, right? That's in general, not even for vertical motion. Get it equal to 0, factor, whether it's greatest common factor or other methods for factoring, and then make each factor, take each factor and set it equal to 0 as its own separate equation to solve for the variable you have using that zero product property.